Hello. In this video we're going to be talking about patterns of 30, 60, 90 and 45, 45, 90 right triangles. So I have here an isosceles triangle, and the reason we know it's isosceles is because two of the sides are congruent. And if we have a right triangle where two sides are congruent, then those angles inside the triangle must be 45, 45, and 90. Okay? If we know one angle is a right angle, and then the two angles across from the congruent sides have to be the same, then they both must be 45, since the two angles in question, the two acute angles here and here, have to add to 90 and be the same. And the only way that works is if they're both 45. Now, it doesn't matter what size I draw this. So if I have a 45, 45, 90 right triangle, where each side is 1, or if I go bigger and I have sides, a triangle where sides are both 2 and it's a 45, 45, 90, or if I go even bigger still, and let's make this so that it's 7, we'll say, and these are both 45, again 45, 45, 90 angles. So it doesn't matter how I draw it. The thing we know about these is that the triangles are similar here by angle, angle. And so that tells us that because these triangles are similar, the sides are also growing based on ratios and proportions. So if the two side lengths are n, and the hypotenuse is n squared root of 2, we can quickly see that in the small triangle, this is 1 times square root of 2. In the triangle where the sides are 2, this hypotenuse is going to be 2 square root of 2. And in the yellow triangle, where there's 7 and 7, it's going to be 7 square root of 2. Because they're all growing at the same rate, so all the sides grow to a specific size, and so the hypotenuse has to do the same thing. And you can do the Pythagorean theorem to check on these, but because we know that these triangles are similar by angle-angle similarity, that we know that 1 times 7 makes 7, so 1 square root of 2 times 7 makes 7 square root of 2, and it should be that. Okay, let's look at our other pattern. Here, I'm looking at not an isosceles triangle, but we know that if we were to flip this over the long leg, we're going to get an equilateral triangle. Okay, now, again, about pattern recognition, we have a short leg, a long leg, and a hypotenuse here. And if we just right away see that the hypotenuse is 2 times longer than the short leg, then this must be a 30, 60, 90. The 30 has to go across from the short leg and the 60 across from the long leg. The long leg is always going to be the square root of 3 times larger than the short leg as well. And the same principle from before applies. If I draw triangles where the sides are 2, let's see here, let's do 2, 4, and then that makes this, we'll just do that for right now. If I draw an even bigger one where the short leg now is 4, that makes the hypotenuse 8. In both of these, we're going to have a 30-degree and a 60-degree angle. So both of these are 30, 60, 90s, we can tell. If I were to draw it so that I have, let's see, might make a short leg. If I make this 3, and this is 3 square root of 3, I can tell because the long leg is root 3 times larger that we're also going to have a 30, 60, 90 right triangle there. And once again, because we have two pairs of congruent angles, these triangles, again, are similar by angle-angle similarity. And so we know that the long leg is always square root of 3 times the short leg. So in the red triangle, this side should be 2 square